the process is pretty much the same. If you recall yesterday, I don't remember if it happened in here, but I think I told you in one of my classes, somebody asked and said, how do I know if I'm done? How do I know if I need to keep going or if I have finished? And the nice thing about verifying identities is that you're going to know if you are finished. Okay, so we'll get to that in just a second and I'll explain. So to verify an identity means to prove or to show that both sides of an equation are equal. Okay, and they are equal for, if you notice, for all values of the variable for which both sides of the equation are defined. In other words, so that's the difference basically between an equation and an identity. So you see this equal sign and you see stuff on each side. If it's an identity, that is telling us any value that you could possibly think of, you can plug into the variables and it's going to give us a true statement. Whereas when we're solving an equation, we have to go through all of this adding to both sides. We have to keep our equation balanced or whatever so that we can figure out the one or maybe two solutions that actually work in this equation. So there's a subtle difference there. And the process that we use is very different. Okay? This is done by transforming the expression on one side of the identity into the expression on the other side through a sequence of intermediate expressions that are each equivalent to the first. In other words, simplifying. As with other types of proofs, each step is justified by a reason, usually another verified trig identity or an algebraic operation. In other words, we've got to use our legal math. We can't kind of make up our own rules. So there are going to be some times that I'm going to point out to you. In some instances, it's easy to kind of get confused and we do something that's not mathematically correct. So you'll see some examples of that along the way. Okay? So when we are verifying identities, somebody in an earlier class commented and said, this sounds a lot like proofs from geometry. And yes, that's exactly right. It's the thought process that we are working through, right? When we are verifying identities, we want to make sure that we are working down the page. You don't want to work across. You're going to work down the page. You've got to make sure you're showing clear steps because here's the deal. Here's what's going to happen. This first identity that we're going to verify looks like this. And we'll get back to this as to why we're doing this, but we're gonna look at this particular expression over here and we're gonna simplify it. We want our answer at the end to be equal to this over here. So that's the nice thing is that we know what we're trying to get to. So you know the answer, so guess what I'm grading is all of those intermediate steps that you have to show me. So that's why it's got to be done in an orderly fashion and down the page so that I can clearly read and follow your thought process on how we get to that point. Okay? So some reminders and some tips. We're always going to start out and work with and simplify the most complicated side. And then remember we mentioned this yesterday also. If you see squared terms, we're probably going to be thinking Pythagorean identities. If you don't see squared terms, probably not, right? Okay, these next few numbered tips, for lack of a better way, are basically all saying we might have to kind of do some mathematics. Like we might need to use some algebraic skills, like we just refreshed our memory on how we find common denominators and that type of thing. So there's going to be some actual kind of like math steps that we may have to do. And then the biggie, if you recall from yesterday, is if you can't figure out anything else to do with the problem, then rewrite everything in terms of sines and cosines and then go from there. Okay, so those are kind of some good tips or ideas or strategies for starting to tackle these problems. The other thing to remember is that we are not solving equations. So the tendency is to see something like this first problem and say, oh, I should add 1 to both sides. We're not solving an equation, so you can't do that. Okay? We're going to do the same process as we were doing yesterday where we're simplifying. We're only going to simplify on one side. So the actually drawing the line down the page kind of is helpful to focus our attention and say, We are only going to do stuff on this side over here. I'm not even going to worry about what's on that right-hand side until I get to where I think I'm done. Okay? All right, so let's try some of these. Left-hand side is more complicated, so we want to work on this side. Some thoughts or ideas. What should we do with that? How can we simplify that? Landon, what do you think? Yeah, let's distribute. There you go. We've got a term on the outside. We need to distribute, right? So we're going to distribute, and we're going to say sine of x times secant of x, and then that's going to be minus sine of x times the cosecant of x. All right, looks like a great first step. All right, now what? Let's rewrite in terms of sines and cosines, all right? So I'm going to keep the sine x the same, but I want to rewrite this secant x. I want to think of that as 1 over cosine of x. And then, actually, guys, we're going to simplify this right away. What is that equal to?
Sine x over cosine x is tangent.
Whoa, that's 1. Because why, Drew?
Because cosecant is technically 1 over sine.
Okay, cosecant is 1 over sine if you need to think about it that way. Or they're reciprocals, and when we multiply reciprocals, we know we get 1, right?
Wait, why can't you, say you put sine x over 1, right? And then you multiply it across?
Okay, let me write that out for you then.
Yeah.
If we have sine x over 1 times 1 over sine x,
Oh, over cosine x.
that's cosecant. What's the reciprocal of
I'm talking about the
cosecant?
one over there, on the left. That's equal to tangent.
Oh, yeah, we're going to get there. We haven't gotten there yet. We're focusing our attention here. So are you okay with that being 1?
Yeah, I was just talking about the other one.
Okay, but yes, you're exactly right. That's the next step, is that we see that gives us sine x over cosine x minus 1. And we know that sine x over cosine x is just tangent of x minus 1. And guys, look at what we were trying to get to. That's what we wanted to get to, was that tangent of x minus 1. So here's the important last step that you must show me in order to receive full credit. And that is, once you get to where you have the same thing on the left-hand side, on the right-hand side, you've got to show me that you know, okay, I have just proven or verified this identity. So that last step is that you're going to say left-hand side equals right-hand side. So you're going to write that, rewrite that and say that at the bottom. Tan x minus 1 equals tan x minus 1. Boom, you guys have just verified your first identity. Nice job. Okay, questions, comments, thoughts?
Are there some that like we're not gonna be able to prove because they're not true, and then we'll have to write
No,
that?
all of the ones that I will give you will work. So it can be helpful to kind of look ahead, but you can't, like, as you notice, like I said, you've got steps to show me. So that's what you're having to do. So just like in geometry where it said, here's what you're given, this is what you have to prove, and you had to fill in all of those steps in between, that's what you're doing here, I guess, right? Okay. More complicated side is definitely the left-hand side. So let's figure out what we're going to do. What do you think? Somebody give me an idea. Sines and cosines. There you go, Avery. I like that. Okay, so let's just rewrite everything in terms of sines and cosines to begin with, and then we'll go from there and figure out what's going on. Okay, so that's my top. I'm going to try to color code for you. That's my top. That's my numerator. My denominator says 1 over cosine x times 1 over sine x. Okay, so I kind of put that as two separate, like 1 over cosine times 1 over sine, but really because that's a 1 over 1 on top, that's That's one nice fraction kind of all together. And the beauty of that is that that's what you have to have. You have to have a common denominator in order to do keep it, change it, flip it. So at this point, that's what I would suggest is we need to do a keep it, change it, flip it. So if we were to do that, now I'm going to write that step separately. So we've got cosine x times sine x. I'm going to go ahead and put that over 1 also. Times, I'm still color coding so you can kind of see what's what. Hopefully that's going to help. Okay, so I'm keeping my numerator the same. Let me highlight that too. So that's my numerator and that's numerator there also, but then I've done my keep it, change it, flip it. All right, I'm going to change colors here. Okay, now what do you think? What should we do? Thoughts, ideas?
Well, like distribute it.
Distribute, right? So we need to multiply cosine x times sine x times that first parentheses, that first term. So we get cosine x times sine x times sine x over cosine x. And then I'm gonna, whoops. I'm gonna multiply that together. And I'm gonna get cosine x times sine x times cosine x over sine x. And then we've got to kind of clean this up. All right, let's just focus our attention here. What can we clean up there?
Cancel out the cosines.
There we go. We can divide out this cosine in the numerator and that one in the denominator. And so we are left with sine squared x plus, on this other side over here, this other term, the sines divide out, and we're just left with cosine squared x. And that looks like someone's identity. Sine squared x plus cosine squared x is 1. And is that what we wanted? Yes, it sure is. So 1 equals 1, and you've just verified your second identity. Nice, huh? I'm hoping you have started to recognize and realize that having these identities memorized is very helpful. I'm looking at some distributing here again. So tan x times sine x plus tan x times cotan x times cosine x. All right, so I've just distributed. So now what? Let's rewrite in terms of sines and cosines. Yep. So let's rewrite that tangent x. And I'll keep this as, I don't know, if it's easier to like put over 1 just so that you can keep track of where stuff is, then by all means do that. I want to do a little bit of simplifying, a little more simplifying in this next step here. What is tangent x times cotangent x equal to? 1, because they're reciprocals. So over here, we just get cosine x over 1. Okay, let's kind of clean this up a little bit. So we have sine squared x over cosine x.
How do you get cosine x over 1? Because I understand that tangent times cosine is 1, but then it's not being multiplied by cosine, it's not being
Yep.
divided. So why is it over it?
It's just cosine, like you can put this over 1 if you need to,
Oh, okay, yeah.
okay? Just to help you realize that's in the numerator, it's not in the denominator. All right, now I'm seeing fractions. We're trying to add them, so we need common denominator. So Common denominator, it means we've got to multiply this term by cosine x over cosine x. And when we multiply that, we get cosine squared x and for that term all over this cosine x. And Andrew's identity is popping up again here, 1 over cosine x, because we know sine squared x plus cosine squared x is 1. And what's 1 over cosine equal to? What we were looking for all along, which is secant x. Okay. Are you kind of noticing some patterns already, I hope? Okay, good. All right, let's keep going. We've got what I think, yeah, 2 more we're going to verify. We got to our memory on some, we did a little, you know what? You guys already did this in the foldable, so we don't need to review this because we already did, right? With finding common denominator. So we're not even going to do that. You guys did that in the foldable. All right, number 4, the right-hand side is definitely more complicated. So we're going to work on that side. And this is one where we need common denominator, right?
Are there somewhere we need to work on both sides?
As much as possible, you want to only work on one side, but there are a few examples. If you flip over to the next page, I do show you some where we're going to do. The key on that is that you do minimal work on the other side. You focus your attention on one side, but if you have to kind of tweak a thing or two on the other, you can do that. But in general, we truly want to focus just on one side. Some mathematicians would say you never work on the other side. You always only work on one side. But others would say it's okay to do a little bit as long as you're not going crazy on the other side. All right, so common denominator. The math purists would be like, oh, that's terrible. So I guess I'm not a true math purist. But that's okay. Okay, so 1 plus sine theta, top and bottom on by the first term, 1 minus sine theta in the second term. So let's think about what we have. In the numerator, we're going to have 1 plus sine theta plus 1 minus sine theta all over. In the denominator, we're multiplying 1 plus sine theta times 1 minus sine theta. Guys, what's that equal to in the denominator? Okay, so sines add to 0 there, and we just are left with 2. And here, this gives us 1 minus sine squared theta. So we have 2 over cosine squared theta. I think for some people it might be helpful to kind of write, like put a times 1 in there to help you think about the fact that this is really saying 1 over cosine squared theta. And what is that equal to? Look at what we're trying to get to. That's going to give you a hint and help you, right? So we've got 2 times secant squared theta, and that is equal to 2 times secant squared theta. Pretty neat, huh? Okay. Yes, although I've got quite a few of these on this page have kind of little tricks or something, like, you know, a little something like that. So this next one in particular does. So yes, I want you to be able to do that, but let's get this one last one, and then actually then you guys are going to get started on homework, and there's some on there that you can do, Luca. All right. If you notice, I'm making a pretty big deal about this type of problem. So stars, asterisks, remember how to do this and remember what you're going to do type thing. That's a pretty safe bet that, you know, this is important to remember. So I want to kind of point out what you should notice with this problem to realize you're going to do this trick and then help you remember what the trick is. So if you notice, it looks like a proportion. Like it looks like if we were solving an equation, we would cross multiply and go from there, right? So that's first thing to notice. The second thing to notice is that in one or more places in those locations, you're seeing a 1 plus or a 1 minus a trig function. So if you see that as well, that's kind of a sign. So the other thing is to notice that like both sides is equally complex, right? There's not one side that's more complicated than the other. So neither side is more complicated than the other. It looks like a proportion, and then you're going to see a 1 plus or a 1 minus a trig function. So what you're going to do to solve this is you are going to focus your attention on the side that has that 1 plus or minus the trig function in the denominator. So in other words, we're going to focus our attention on the left-hand side. And what we are going to do in order to solve, I would suggest you write this down in your notes, is you are going to multiply by the conjugate. So we're going to multiply the left-hand side times the conjugate. So you got to remember what that means, right? So yeah, so that means we are going to multiply. We're not worrying about the right-hand side. We're going to focus our attention over here, and we're going to multiply by 1 minus cosine theta. 1 minus cosine theta. Just the reminder of what that special trick is in these circumstances. You may want to make a list of those 3 things I kind of mentioned too, if you feel like you need to. Both sides are the same in terms of how complicated they are. Looks like a proportion, and there's a 1 plus or a 1 minus a trig function. So remember, those 3 things are what you're kind of looking for. Okay, so I will tell you that in many instances, not all, in many instances with this type of problem, you're actually not going to want to distribute because we're going to see stuff that's going to divide out. So to begin with, my suggestion is do not distribute. If you have to go back and distribute to see if something divides out, then you can, but let's check before without. So in the denominator, we are going to get 1 minus cosine squared theta when we FOIL that. That's the key with the multiplying by the conjugate, is that we're going to get that, right? So then think about the fact that we know that, let's keep the numerator the same.
1 equals sine squared.
Yep. So that denominator is equal to sine squared theta. And so then what happens with these signs? One of these divides out with one of those, and what are we left with? 1 minus cosine theta all over sine theta. And that's what we wanted. So we've got it. We did it. You wouldn't, I don't think you'd see it as readily, because if you distributed there, sorry, I'm looking at Luca, so, sorry, Jude. If you distributed there, I'm going to write this off to the side, and then I'll erase it again. But if you distributed there, you'd have sine theta minus sine theta cosine theta, and then that's all over sine squared theta. You may or may not see that, like, you basically would have to factor the sign back out to clean that up. Do you see what I mean? So it's nicer looking, and it's easier to see the reducing that you have to do, the dividing out you have to do with it not distributed. All right, you've got 10 minutes, and that's about what I was hoping for you to have. Your classwork / homework is page 10. And if you look on that page, there's some simplifying at the top, and then there's some verifying at the bottom. So you decide, work with a neighbor and ask questions of me if you need to also, but if you feel like you need more practice with just getting to the simplifying first, then do that and then work on the verifying. If you feel like you want to jump to the verifying first and then go back and do the simplifying, Either way, your pick, right?
Then how you-
Just hold on, go
Oh,
Nicholson.
stick it all in.